Kramer's rule in modified form can also be applied for larger systems of linear equations. To state this rule for systems of three linear equations with three variables, we need to define determinants for 3 by 3 matrices, that is, for matrices that have 3 rows and 3 columns. So suppose we have the table, they have matrix A, B, C, D, E, F, and G, H, I, and we are trying to compute that determinant. So again, we are using the same notation, two vertical lines that enclose the rows and the columns. There are many ways to define 3 by 3 determinants, but we'll use only one that takes into account the 2 by 2 determinants. And we'll use the first row to do so. So we'll start with the first entry in the first column and the first row. And the definition says, take that entry and multiply by the determinant that is obtained by crossing out the row and the column that A is in. If we cross that row and the column, we'll have determinant EF, H, I. Then we'll subtract the second entry in the row, B, times, and we'll form the determinant by crossing out the column B is in and the row B is in. So we'll have D, F, G, I. And then we add the last entry in the first row, which is C, and multiply it by the determinant that is obtained by crossing out the row and the column that C is in, and therefore determinant with entries D, E, G, and H. So this is the definition of 3 by 3 determinant. Let's do an example. We have determinant where the numbers are in the first row 1, negative 3, 4, in the second row negative 2, 2, negative 5, in the third row 3, 4, and 1. So we'll start with the first entry in the first row and the first column, which is 1. So that's going to be 1. And we multiply this 1 by the determinant obtained by crossing out the column 1 is in and the row. And that determinant is going to be 2, negative 5, 4, and 1. Then we'll subtract the second number in the first row, which is negative 3. So we subtract negative 3 times the determinant that is obtained by crossing out the row negative 3 is in and the column. So the numbers are negative 2, negative 5, 3, and 1. And then we'll add the third entry in that first row is 4, and we multiply that 4 by the determinant that is obtained by crossing out the first row and the third column. So this is going to be determinant with the entries negative 2, 2 in the first row, and 3 and 4. At this point we know the determinants, 2 by 2 determinants, so we can start evaluating this. Multiplying by 1 is not going to change anything, so the first determinant is 2 times 1 minus 4 times negative 5. Then we'll have minus 3, so this is going to be plus 3, and the determinant is going to be negative 2 times 1 minus 3 times negative 5. And then we'll have plus 4, and determinant is negative 2 times 4 minus 3 times 2. And now we'll have to evaluate each product and each difference. So we have 2 plus 20 plus 3, and in the parentheses we'll have negative 2 plus 15, that's plus 13, and then we'll have plus 4 times, and in a parenthesis we have negative 8 minus 6, so this is negative 14. And therefore we'll have 22 plus 39 and then minus 56. And that is 22 plus 39 is 61 minus 56. The value is 5.